Hello and welcome to the Abingdon Physics YouTube channel. Today we're going to be looking at Edexcel, IGCSE, topic 3, waves, in particular the EM spectrum. So this part of the course only has 4 spec points relating to it, and they are all related to the different parts of the EM spectrum. So let's get into it. So our first 2 spec points are to know that light is part of a continuous EM spectrum that includes radio, microwave, infrared, visible light, ultraviolet, X-rays, and gamma ray radiation, and that all of these waves travel at the same speed in free space. We should know that that speed is 3 times 10 to the 8 meters per second, and will commonly be referred to as the speed of light. We should also know the order of the EM spectrum in terms of decreasing wavelength and increasing frequency, including the colours of the visible light spectrum. We should know that the radio waves have the largest wavelength, then microwaves, then infrared, then visible light, then UV, then X-rays, then gamma rays. All of these rays travel at the speed of light in a vacuum. Therefore, if the wavelength is largest towards the radio end of the spectrum, the frequency will be the smallest towards the radio end of the spectrum. And if the wavelength is smallest towards the gamma end of the spectrum, the frequency will be largest towards the gamma end of the spectrum. It is also important to note that UV, X-rays, and gamma are all ionizing, and this means they are dangerous, basically. They can cause ionization, UV causing the least ionization, gamma causing the most ionization. We should also note that red has the largest wavelength of the visible light spectrum, and violet has the smallest wavelength of the visible light spectrum, and that makes sense as it's slotted perfectly between infrared and ultraviolet, and that is the way I find most useful to remember. So we also need to know a use and danger for each different part of the spectrum where this is appropriate. So a use for radio waves is radio communications. So they are used to transfer information for communication over large distances. There's no real dangers of radio waves, so we can move on to next, which is microwaves. And one of the main uses of microwaves is to heat up food. So they are used in cooking, but they are also used in satellite communications. However, microwaves do have a danger that they can cause heating of internal body organs. Next up, we have infrared, and infrared is often used for heaters and night vision goggles. It's also used in our remote controls to turn on our TVs. A danger of infrared, though, is too much exposure to infrared can cause skin burns. Now we're into the middle of the spectrum, we have visible light. A use of visible light that we can never say. Please do not say for seeing. It's never in the mark schemes. What I want us to use instead is I want us to say optical fibers, photography. These are the types of things I want us to be saying. So something where we're capturing an image. There's danger of visible light. It could appear that you could say blindness, but I would prefer that you put that under the next one, which is UV. So UV, the dangers of UV would be damage to skin surface cells and blindness. A use of UV is for fluorescent lamps, used in crime scene analysis, used to detect fake banknotes. Next up, we have X-rays. So a use of X-rays is for medical imaging, but it is also used at airports for seeing into our bags. And so we can say they are observing the internal structures of objects and materials. A danger of X-rays, if we're exposed to too much of them, because they are ionizing much like UV was, they can cause cancer. And that's why when we have our X-ray technicians in the real world, you'll notice if you've ever been to get an X-ray, the technician will stand outside of the room. And that is so that their exposure to X-rays is minimized. So the best way to stop being exposed to X-rays is by going away. And finally, we have the most potentially harmful, and that is gamma rays. So gamma rays are really dangerous because being too exposed to them can cause cancer, it can cause cell mutation, it can cause the destruction of your DNA. However, gamma rays can be very useful for sterilizing medical equipment and removing all the bacteria off it. They can also be used for sterilizing food for long haul transport, and they can also be used for treating cancer. So within chemotherapy, that is the targeting using gamma rays to try and destroy the cancerous cells. So now let's look at a couple of questions for EM wave. First off, we have a true or false statements within boxes. So all EM waves are longitudinal. This is not true. They are all transverse waves. All EM waves travel the same speed in free space. This is true. They all travel at that speed of light, so we can add a tick here. Radio waves have the longest wavelength in the EM spectrum. This is true. X-rays have the highest frequency in the EM spectrum. That is not true. Gamma rays do. All electromagnetic waves transfer energy. This is true. And all electromagnetic waves cause cancer. This is not true. That is only the ionizing ones, so UV, X-rays, and gamma. We are now asked to give a use and a harmful effect of microwaves. So a use of microwaves, we could say cooking. We could also say satellite communications if we want to. A harmful effect could be heating of internal body organs. It's important to note we cannot say cancer for microwaves, as that's not true because they are not ionizing. However, give one use and one harmful effect for gamma rays. We can say one of the uses is for sterilizing medical equipment, and one of the harmful effects of gamma rays is causing cancer. And if we look at our mark scheme here, we can see the microwaves have the use for communication or heating food, with the harmful effect of internal heating, whereas gamma rays have the valid use of sterilizing food, medical equipment, killing microbes, treating cancer or medical tracing, and a valid harmful effect of ionization or a risk of cancer. Okay, and then we have our next question to give a harmful effect of infrared waves, and I would go for skin burns here, and it's important that we're trying to use the language burns, as infrared causes burns, not cancer again, because it's not ionizing. Moving on, we're asked to give two similar properties of visible light waves and infrared waves. The most obvious one is that they have the same speed in a vacuum and that they also transfer energy. There are lots of different options we could have gone for here, and these will appear when we get to the mark scheme. We're also asked to give two differences between the properties of visible light waves and infrared waves, and the most obvious two are that they have different wavelengths and different frequencies. It is important to note with these two questions we are talking about properties of the waves. This does not mean what they are used for and their dangers. So the answers would not be something like infrared waves cause burns, whereas a visible light does not. And so if we see our answers against the mark scheme, we see burns again at the top, and we have both waves are EM waves, both transfer energy, both transverse, both non-ionizing, both can travel through a vacuum, and both have the same speed in that vacuum. And the differences are the change in wavelength and the different frequency. An important point to note is that they have said that the infrared has a higher wavelength and the infrared has a lower frequency. So we need to be specific about which one has the higher wavelength and which one has the lower frequency when answering these questions. So our final question, we are told X-rays and gamma rays are examples of ionizing radiation. Which of these is another example of ionizing radiation? And that should be D, ultraviolet. We are then asked to give one use of X-rays and one use of gamma rays. Well, we've already done the gamma rays one earlier, so we'll say sterilizing medical equipment again, and the use of X-rays can be for medical imaging. And if we check these against our mark scheme, we see that one of the uses of X-rays is for taking photos of detecting broken bones or internal structures, i.e. medical imaging, and one use for gamma rays is sterilizing medical equipment, radiotherapy, reference to tracing, airport scanning of luggage, or irradiating food, and they also allow treatment for cancer. And with that, that is the entire EM spectrum topic done. Thank you for watching. Make sure you are doing lots of practice questions. Please make sure you like and subscribe, and you keep paying attention to these videos going forwards to help with your learning. Right, do some practice questions. Bye.